Airspeed indicator system. Airspeed indicator principle. The airspeed indicator is basically differential pressure gauge which measures and indicates the difference between pitot and static air pressure. The airspeed indicator consists of primarily of a sensitive metallic diaphragm that responds to pitot static pressure differential and multiplies this movement through mechanical linkages to indicate the aircraft speed on the dial face in terms of knots or miles per hour. The majority of airspeed indicator are marked to indicate speed limitation at a glance. The never exceed velocity is designated by a radial line. A yellow arc designates the cautionary range. A white arc is used to indicate the range of permissible limit for flap extension. These are the terms used in the airspeed indicator principle. Mach meter. Mach meter installed on board high performance aircraft, which will indicate the ratio of aircraft speed to the speed of sound at the particular altitude and temperature existing at any time during flight. A Mach meter usually consists of a differential pressure capsule which senses pitot static pressure and aneroid capsule which senses static pressure. The action of these capsules are mechanically resolved to display Mach number on the face of the instrument. Combined airspeed as well as Mach indicator is given here. So which will usually provide where instrument space is at a premium. It is desirable to the present this information on a combined indicator. These instrument display indicator airspeed, Mach and limiting Mach by means of a differential pressure and aneroid diaphragm. The combined airspeed and Mach indicator uses a single needle which indicates airspeed on a fixed scale and Mach on a rotating scale. A knob located on instrument is provided to set a movable index marker to reference a desired airspeed Mach setting. Maximum allowable airspeed Mach indicator have Boltzmann maximum allowable, intended for use in subsonic aircraft, will provide airspeed Mach maximum allowable airspeed indication in a single instrument. The indicator comprises two separate capsule mechanisms: stationary airspeed dial, moving Mach subdial, single airspeed pointer, maximum allowable airspeed indication, index marker, which can be rotated by means of a knob in the lower left-hand corner of the instrument. A white pointer indicates airspeed against a fixed subdial calibrated from 60 knots to 400 knots. Mach number against a moving Mach subdial calibrated from 0.3 Mach to 1 Mach. Maximum allowable airspeed is indicated on the dial by a yellow and a red marker. The index marker is basically a manually set command bug that permits pilot to select a desired approach speed, provides signal output to drive the fast or slow speed command needle on the attitude direction indicator. The speed command output signal are determined by the difference between airspeed pointer and index marker. The indicator also provides airspeed hold, Mach hold, AC and DC airspeed, Mach analog output for use in the flight control system. So functional description of this indicator comprises primarily of two mechanically independent diaphragm operated mechanism, one responding to the differential pressure between pitot and static pressure, the other to static pressure only. The airspeed mechanism of the indicator is driven from a diaphragm capsule with pitot pressure introduced into its interior, while the exterior of the diaphragm is subjected to the static pressure introduced into the instrument case. The capsule expands approximately linearly with the indicated airspeed. The motion of the centerpiece of the capsule is transmitted to a jeweled rocking shaft by by a dual link and lever management. One link is connected to a short lever on the rocking shaft, which is at a nearly right angle to the link. This lever is lengthened or shortened to provide the correct calibration of the pointer on the spread out linear section of the dial up to 200 knots. At 190 knots, the second link comes into contact with its lever. The second lever is longer than the first, and at 190 knots is more nearly in link with the link. This angular relation between link and lever converts the diaphragm linear motion to rotational movement linear with the log of differential pressure. This non-linear portion of the dial above 190 knots is required in order to correctly indicate Mach. Both links are slotted so each can over travel while the other is active. A hairspring on the rocking shaft provides a tension on the active link at all times. The rocking shaft motion is amplified by a step-by-step gear pair to turn the jeweled pointer shaft. Damping of the airspeed pointer is accomplished by a capillary tube through which the pitot pressure is fed into the capsule. The indication is compensated for ambient temperature changes by selection of the material for the frame, linkage, and capsule. Static balance is achieved through an adjustable counterweight on the rocking shaft and a balanced pointer shaft. The max subdial is driven from an evacuated diaphragm capsule through a link lever rocking shaft gear up stage. The capsule expansion is linear with the pressure altitude, and when modified by link and lever, the subdial is rotated in proportion to the log of static pressure. In the manner of a circular slide rule, this causes the correct Mach number for any altitude to appear opposite the corresponding airspeed value. The airspeed pointer indicates both Mach and the airspeed over the range where the subdial is visible.